Hi everybody, welcome back to this video series. In this video, we are going to cover the second part, which is on the deployment of Flower FL tool on the local machine using Docker. First, we are going to understand the contents of the Docker files. There are two Docker files, one for the server and one for the client. And based on these Docker files, we are going to build the images for the server and the client. Similarly, there will be one image for the server and one image for the client. Each of the three participating clients will use the same client image. The only difference is their local dataset being used in those images. And after building the images, we are going to run the containers for these images. We are going to run one container for the server, and we are going to run one each container for each of the participating clients. So there will be three containers for three participating clients. Let's have a look at the files. We have two folders here. One is for the server and one for the client. For the server folder, we have this same pyproject.toml file that we have seen in the previous video. Same goes for the readme.md file. We have this Docker file now, which contains the list of commands that will be run when we build this, when we build the image for the server. And then we have a server Python file. We have modified this Python file a bit as compared to the previous version, which we have seen in the previous part. And the modification is that instead of hard coding the value of the IP address and port number for the server, we are asking the user to enter these two variables, the IP address and port number for the server. So if you see the contents of the Docker file, it has these 5 commands, starting from taking the base image of Python and then setting the working directory of the container to this /app. So everything which will be run from this container will be run from this working directory of /app. Then we are copying all the files from the current directory of the host machine, which is server in this case, to the current directory of the container, which is /app in this case. So all of the files in this server folder, pyproject.toml, readme.md, and the server Python file will be copied inside the current directory of the container, that is inside this /app. And then we are installing all of the libraries, all of the requirements which are mentioned in this pyproject.toml file using this command of run pip install dot. And after that, we are running this server Python file. Now, if we look at the contents or the files of this client folder, we have the same readme.md file. We have the same pyproject.toml file. For the client.py, we again have this small modification of having the IP address and port number being taken from the user instead of hard coding these two variables. Also, we are using this data.csv file, which is there in this client folder. This data.csv file can be any CSV file. It's just there for the sake of for the sake of creating this Docker file. Later, when we run the containers for the 3 participating clients, each of the participating client will provide their own local data set, which will be replaced by this data.csv. I'll talk more about that when we run those containers. And if you look at the Docker file, it has the same 5 commands, starting from using the base image of Python, setting the working directory of the container to this /app, copying each and everything, including the data.csv file to the working directory of the container, which is /app, then running or installing the required packages or libraries which are mentioned in this pyproject.toml, and finally running the client Python file. Now, to run or to build an image based on the Docker files, we can use Docker, specifically there's a command docker build, and then providing the name of that image by specifying the flag of this -t, which stands for tag, and then specifying the name of the image. Let's say the name of the image. By the way, I'm inside this server folder, so I'm going to build an image for the server. So let's name this image as server image, and then this image should build from the Docker file, which has a name of flower. Sorry, server underscore flower.dockerfile. So this -f is specified a flag -f for the file name of the Docker file. Lastly, we have this dot, press enter, and it will start building the image based on the commands present in that Docker file. It will take a bit of time to build this image. Luckily, I have built the images for the server and the client before recording this video, and we can see those two images in the Docker GUI. We have this one image named as flower-client-image for the client, and this flower server image for the server. So we have built these two images, one for the client and one for the server. And after building these images, we are going to run the containers for these two images. So let's run these images. Let's stay this as it is and open one more window. Okay, let's run the server container first. And to run a container, we are going to use docker run and then a flag of -it, which stands for the iterative mode, because we are going to we are going to take the values of two variables from the user, the IP address and the port number of the server. So that's why this -it, and then the name of the container. So let's name this container as flower underscore server, and let's say container. And then we need to specify the network, and we are going to use the host network. And the reason of using this host network is that we want to use the same IP address of the host machine. If we don't specify this host network, what this container is going to do is going to use the IP address which is associated with the container. We don't want that. We want to use the same IP address which is associated with the local host instead of this Docker. So we are going to use this network of host. And finally, we need to specify the name of the image. So we have this flower-server-image. So flower-server-image, and run this. Yep, and it runs that server Python file, and it's asking for the IP address for the server and the port number. Let's give it as 5001. And it has started, and at the moment it's requesting the initial parameters from one of the random client, and hopefully when I run one client, that client will provide the initial random model parameters to this server. This server will then distribute those model parameters to each of the participating clients, and then those participating clients will use those model parameters to train those on their local data set and send the train model back to the server, so that server can aggregate those, and so on and so forth. And this process will carry on for 50 number of rounds as we have specified in the server Python file. Now for the client to run a container, it's almost the same with one exception. So we'll start with the docker run, and then in the iterative mode. And then we need to provide the file for the local data set for a specific client. Let's say we are running this Docker for the first participating client. So we need to specify or need to provide the local data set, which is there in data_1.csv file. So we need to specify that file to this image. In Docker language, we need to mount the volume of the local host directory to the container directory. So we are going to replace this data_1.csv file with the data.csv file, which is present in the container directory. And to do that, we are going to use this -v flag, and then we are going to specify the location of that file, which is data_1.csv file. So at the moment I am inside this client folder, which is here, client folder, and I believe the data folder is here. So I need to go back one directory, and then inside this data file, and then need to specify this data_1.csv file. So I start with the working directory, print working directory, then /1 directory back, then data directory, and within the data we need to specify the data1.csv file, and we are going to mount this to the working directory of the container, and that was /app/data.csv. So what it does, it's going to replace this data_1.csv with the data.csv. So when this container will run, it will take the contents of this data_1.csv file instead of that hard-coded data.csv file. And then as we have done in the server case, we need to specify the name of the container, and let's name this container as Flower client 1 container, and then need to specify the network again, which should be the same network, in this case network host, and lastly the name of the image that we want to run, which is flower-client-image. And that's pretty much it. Okay, it says it's not a directory. Quick on this under Docker. Yeah, I need to go back one more directory actually. Yeah, sorry about that. And because we have created this container with the name of flower_client_1_container, we need to delete that before we can recreate this one. So I'm gonna select this from the container tab. I'm going to delete this and back to this terminal, and updating the directory for the host one. I believe we need to go one more directory to the upside. So running this, yep, it's asking for the IP address for the server, which is 127.0.0.1, and the port number is 5001, which was used in the server case. So yeah, when I run this, you can see that it has sent the initial global model parameters, the random one, to the server, and server has received those. We are going to run one more container for the second client. Let's copy this whole thing. Obviously, we need to modify a couple of things. One is the name of the container. Let's name it as a flower_client_2 container, and then the data file that we want to replace. And yeah, we are going to use the same client image that we have built, and that's pretty much it. Run it. the IP address for the server, the port number which was 5001, run, and similarly for the client 3, rename it to 3_container, and the local data file should be data_3. It should ask for the IP address, yep, and the port number, and yep, it's running good. So again, we can see the values of those different evaluation metrics, loss, accuracy, and the accuracy on the testing data set for each of the client. So yeah, in this video, we have gone through these contents. We understood the contents for the Docker file. We have built the images for the server and the client, and we have run the containers for the server and 3 participating clients. That's pretty much it as far as this video is concerned. In the next part, we are going to implement the Flower FL tool on the Nectar cloud. Thank you.